Good morning. Well, good afternoon, everyone. I'm Riccardo Rossini, and I'm a salesperson for Italy for Enologica Vason. The Vason Group has always had the mission of combining innovation and equipment innovation. Today, we're presenting what we feel is a revolutionary project, the goal of which is to preserve the identity of the wines and their styles through new generation technologies. Our R&D development and evolution has led to the development of this juiceless with a synergistic effort with Professor Zattoni of the Bioflow spin-off of the University of Bologna, who studies colloids in their native form. His studies provides a brand new perspective in the study of filtration technologies. And then Giotto Wine Listeners is represented here by Federico Giotto, the founder, active internationally in business consulting for its a cross-disciplinary approach with a contribution on the definition of the technical and sensory objectives and the proposal of innovative solutions to preserve the complexity and quality of the wines. The research and development team, Juclas of Enologica Vason, led by Marco Marcone, introduced the analytical approach in an applicable, robust technology that combines sustainability, technical precision, and respect for the complexity of wine. My speech will introduce the three main axes of the project that the speakers will deal with. First is the understanding of colloidal dynamics with techniques that screen particles by size. This provides a new understanding of colloidal systems in wine with important implications in quality management. The second will analyze the new approaches for quality filtration. There are two key concepts that will open up two new perspectives. First, reverse flow capillary membrane filters that can select the colloids in a selective way, and then the adaptation of flows to the dynamic characteristics of wine. This converges into this idea of dynamic filtration or flux-dynamic filtration. The third aspect will clarify how technology adapts to wine to obtain significant results. As a matter of fact, it is fundamental that technologies adapt to wine and not the other way around. So this implies flexible methods of work that can valorize the characteristics of individual cuvées. So our technological system will follow the wine and not force it. And then Mastermind by Juclas will more respect the original quality of wine, preserving its sensory identity and its natural complexity. A sustainable, flexible, low energy consumption solution in line with the needs of modern wineries, and a contribution to competitive differentiation in a crowded and increasingly crowded market where the edge is gained when you can communicate your uniqueness. Thank you for listening so attentively, and I'll now leave the floor to the other speakers. Thank you very much for your introduction. Let's now move on to Andrea Zattoni for the University of Bologna. Good afternoon, everyone. Thank you for your introduction. We've already seen the presentations. Let's deal with the subject. I will introduce the F4 technique, that is the technology, which is one of the bases of the project that we're about to present. The FFF is a technique, we're talking about flow dynamics, which is of a chromatographic nature. It separates macromolecules and particles. This technique has existed for several decades. It was developed approximately by the mid-century in the 20th century, at a time when nanotechnologies and the interest for colloidal systems has boomed in every field, from food to pharmaceutical to chemical. These techniques find their most successful applications. There are several techniques that are based on similar principles, but slightly different actually from one another. And the separation happens to within an empty channel, an empty field due to external factors. The technique that has been most widely accepted, implemented, and successful is the asymmetric flow technique. In this technique, the particles are sent through a membrane, an ultrafiltration membrane, and the hydrodynamic field will retain them at different times. So they are separated in the fractioning channel based on their size. More quickly, the small ones and more slowly the big ones. So what are the key characteristics of this technique? First of all, it is a separation by size under soft conditions, because in the fractioning channel there is no stationary phase, and so the interactions of colloidal systems with the separation system are extremely soft and smooth. We can consider the interactions that these colloidal systems are creating in their native environment even after the separation. And this in a big range, a big interval from 1 nanometer to 10 microns. Covering the entire field of colloidal systems. The equipment has been developed during several decades, and now it is available on extremely automated commercial platforms that are compatible with any quality control system and compatible and compliant with characterization procedures in the pharmaceutical field as well as in the food field. The instruments, because they are of a chromatographic nature, they can work in AF4 or chromatography, and it can be coupled to a number of traditional chromatography devices, spectrometers and fluorimeters, and the multi-angle scattering systems that can provide real-time dimensional characterization, as well as the characterization of molar mass for what we're looking for, plus other couplings with mass spectrometry or bioanalytical techniques to increase the volume of information that we can distill. These multi-dimensional platforms provide big amounts of information that converge into producing a fingerprint of the colloidal system, in this case wine, that can provide a lot of help in understanding the processes at play in the system itself. Of course, there are other techniques that can be applied to the characterization of the colloidal component. These are techniques that do not provide for the preventative separation of the colloidal components, but they work directly on the sample. But they have limits. For instance, the dynamic scattering is not a separation technique, and so it has a hard time characterizing dispersed samples. The SEC has a stationary phase, and so there can be big interactions with the colloidal systems, and also more innovative techniques such as the tracking techniques such as NTA require high dilution levels, which reduces the representative character of the sample. Our platform with AF4 and all the detectors allows us to work in native conditions using simulated ones with the same components as the real wine, as the mobile element, as the sample, and spectrometric information. We can work in a number of different ways through separation or not, highlighting the information that we can receive from the detectors and the information that we obtain from separation out of a total colloid content or on the detail of the various sizes that are separated through this technique. A few examples that we have obtained recently and published recently in cooperation with the Padua University for red wines. These are the results of this project that will be presented in the coming presentations. As you can tell, we can obtain multidimensional charts, 3D charts for absorption that show that each colloidal population is made up of different subpopulations of different chemical origin, proteins, polysaccharides, polyphenols, and complexes of the same. Another example is the fluorescence revelation, which is specific for protein contents, proteins and nanoproteins, referring to the sample at the specific wavelength. In conclusion, overall, for each sample, we obtain an actual fingerprint, as I said, which is a plot where the different populations of colloids are diluted as a function of time and size. The scattering gives us specific information on the distribution by size of individual populations, while the chemical information allow us to characterize the composition of the colloids. One of the results of the previous studies was that we could assume the presence of aggregation mechanisms among the various colloidal components that allow us to see the various colloids in the wine as a function of the aging time, the time since the uncorking of the bottle. But these are just a few examples of the potential of this technique in wine applications. There can be other applications spanning from the characterization of the vinification process, that is the colloidal content during production, the characterization of protein stabilization and fining, including those by type of yeast, and then the monitoring of all processes. That's a very quick one, because I would like to highlight that all the information is obtained in just in excess of half an hour by the equipment itself, with the characterization of all the evolution of colloids during, for instance, micro-oxygenation. In conclusion, I would like to thank and acknowledge the people who cooperated in the making of this project and the University of Padua that was instrumental in starting this area of research, approaching this area of research. Thank you very much. We'll continue with Federico Giotto of Giotto Wine Listeners. I'm so pleased to see that everybody is so quick, because I tend to take a lot of time when I give speeches. Okay, thank you very much for inviting us here. It is a very prestigious podium to be at, and I would like to thank the speakers before me for creating the context for this research project to thrive. Andrea, with the incredible technique that certainly up until a few years ago, or at least in the winemaking field, would have made it difficult to study colloids in wine individually. I have the task to take you to another field that is a very interesting experiment that perhaps also questioned some of my convictions that I used to have in the area of filtration. I'm part of the Giotto Wine Listeners. It's a company that provides viticultural and winemaking consulting. But as part of its DNA, it has always had research and development, because we are convinced that research is essential and that exchanging opinions is essential in growing the quality, especially the quality of wine. 15 professionals are working for Giotto Wine Listeners. We have in excess of 50 active collaborations in 9 countries around the world. The winemaker's mantra is just one. We needed to preserve what we've been able to produce during grape growing and then vinification. But throughout the production stages, wine encounters many threats. And one of the most significant is filtration. Why do I call it a threat? Because if on the one hand, you needed to present to the consumers a stable and clear product with microbiological stability and within certain limits. We know that filtration is subtractive. It subtracts instead of adding. So there's always a fear, and not without a reason, that if filtration is done as it should, we are also taking away components from the wine that it would be important to keep. And here the most important focus in this case is colloids, based on what you've heard from the previous presentations. It's a family of compounds that we've just started addressing in depth that can transform into one another. And what is the approach to filtration that would allow us to maintain the colloids in wine, to keep them in wine, and to keep them to the best possible quality level, thus leading to the best possible wine quality? Before I delve deeper into the filtration process, let me discuss something that is often taken for granted. I often hear people say we've filtered wine without fining it. Perhaps that's not the best approach, because taking a sectoral approach when it comes to wine and understanding that filtration is just a process that needs to be associated with other processes, including those that lead to the preparation of wine, certainly is a key aspect. That's why you don't have a standard fining method, let's call it a technique for identifying the wine more clearly, for defining the wine, because taking a tailor-made approach at the lab and understanding how certain fining agents work means having a double strategic advantage. First of all, you preserve the quality and hence the identity of the wine. And secondly, favoring filtration, because the wine is readier for filtration. Okay, let's go back. Classification techniques can be orthogonal or cross-flow. Orthogonal are on the surface or going deeper. Cross-flow filtration is not what we're going to do today, to take care of today, but it's very important in winemaking. We're going to focus on filtration before bottling, not the final filtration, but the one before bottling. Certainly, across the years, a few benchmarks have been identified. That is, filters that have given an opportunity to produce better quality and then the rest of them. And these are all orthogonal filtration benchmarks and methodologies. And we have dealt with two of the most important systems that are available today. The first is the big, deep cartridges, multiple stage cartridges, and then you also have the cartridge housings, because they need to cover a big surface, that help prepare the wine before bottling. Now, our assumption was a two-way approach because it took into consideration two concepts. On the one hand, to use a membrane with a very large surface area, that is a capillary membrane, reverse flow, and we'll see what it means in a moment, combined with flow conduction. Apparently, you may know what this is, but I doubt it. You may think you know it, but I doubt it. It's very similar to cross-flow membranes, but the wine will circulate from the outside in. So imagine what enormous surface we can have in a very small space, in a very small area. On the other hand, the shape of such a membrane, which is an outside-in membrane favors another aspect. You have fewer turbulences and hence fewer mechanical breakages of colloids. And perhaps the next presentation will clarify the rest. Anyway, the membrane architecture is not the one thing that you need to take care of. Generally, when you filter a wine, the filter will become clogged. You try to augment it, to increase the pressure to keep the rate constant, but that is not always the best option. What happens, in fact, is that normally we will compress the cake, that is the fouling in the membrane, creating a filter in the filter. But when we think we are filtering a wine at 1 micron, when we increase the pressure, we're filtering at a much smaller size. And we therefore remove not only what we would like to, but also a lot more than that. It is therefore clear then the second assumption had to be, why don't we regulate, why don't we adjust that pressure via sensors so that we can work within the optimum window, the optimum filtration window. We did not invent anything when asking ourselves that question. It's a well-known thing, especially when you need to select certain proteins in the medical field. There's a filtration window that needs to apply. Now, let's see if the results are showing the interest of this assumption and solution. Let me present 2 case studies. The first was a base wine for spumante, a Franciacorta. The second was a fermented spumante, a fermented sparkling wine. In the former case, we compared a cartridge filtration side by side with the system we're proposing. In the second case, we had the big cartridges versus our system. I should mention that this is not an exclusive filtration for sparkling wines. However, sparkling wines are extremely sensitive and therefore they can act as a lens, especially for certain colloids that we're going to have a look at. So they are difficult matrices, but because of the purpose of this study, they could offer an interesting approach to understand what happens when you filtrate wine. When it comes to analysis methodologies that we've decided to use, and this was shared with Andrea, with AF4, this huge eye that we have to analyze the colloids in wine, this great instrument. And then thinking of sensory analysis, we also adopted that approach, the basic wine analysis, and also this being spumante, we also use the Mosalux method. Now let's look at the details. Other than the charts, that Andrea could read much better than I can, let me give you the gist of this. The first case that we saw, that we analyzed, that was the case where we filtered with cartridges in the new filtration system a base wine for Franciacorta. Well, what you can infer, and that we were pretty stunned at initially, was that cartridge filtration, if you look at the chart at the bars on the left-hand side, had more small colloids than hybrid filtration. However, at some point we realized, as you can tell here, that there's a higher amount of colloids also compared to the control wine. When you investigate the chart, especially with peak 6, where you have the larger colloids, you see a substantial difference between the larger colloids in hybrid filtration than as is. So what happens was that the multi-stage filtration using cartridges probably caused a mechanical breakage of the colloids. Well, actually, we're sure of that. And therefore, we have a higher amount of colloids of small dimension, of small sizes, But the filtration system that we offered with this capillary membrane with dynamic control was preserving the profile of the wine. In case number 2, we have the filtration of a spumante, so a finished spumante. Why a spumante? Let me say again, in this case, this was a Martinotti spumante made in a pressurized tank using a company filtration system that probably removed part of the colloids. What we tried to understand here in a more specific way was how filtration can behave vis-a-vis colloids, including monoproteins, released by the yeast during secondary fermentation, because we used the same one and the same tank and separated the amount into 2 lots. This can provide us an indication that is not exclusive for sparkling wines, but if you have a Chardonnay that has spent time on the lees for 6 months, so losing that volume that you feel to the palate is not something we want. So if you look at the chart, all the peaks measured by AF4 gave a significantly higher readings than cartridge filtration for our filtration system. And then let me also add, when people say that colloids are formed again, these are analyses that we carried out at 6 months. And it's true. We saw it's true. There's a certain ability on the part of colloids to form again, but that is not an excuse, a good excuse to not filter properly, because the difference would be as significant after 6 months between the 2 samples. So here you have the Franciacorta base wine and then the Prosecco spumante. The new filtration method, the capillary filtration with flow control, dynamic flow control, made it possible in the last 2 charts on the bottom of the page to have a time of foam persistence that was much higher. What might sound strange, but is not, is seeing that the height of the foam in cartridge filtration is slightly higher in the cartridge system versus the hybrid system, although not significant statistically. But this also confirms the data that we saw when using the AF4, because if you remember, the shear stress led to having smaller colloids, and these smaller colloids, which are also proteins, will make it possible to have a slightly thicker foam. But we've reduced the permanence of the foam by 30 times, by a factor of 30. So if you see that in foam, it also has an effect in terms of tasting and in structural terms. Something else that I'm going to, that it is important to mention, and that will make dynamic flow control important, is that for each membrane, there's an operational window for it to work well. And that is not just based on the membrane, if you have a cartridge filtration system, but also within membranes, with the capillary flow membranes or reverse flow membranes, you can have totally different characteristics, so much so that we have decided to try with a larger mesh, and what we saw in that case was that the operational window was much narrower, and that's probably because within the pore you form some sort of filter in the filter, a filter-in-filter effect. Now, this is not something that you can tell from the bar charts, but these results sort of reassured us, because here we compared filtration at different pressure levels, 0.2 and 0.8 bars. Depending on the membrane, we received a different response in terms of tasting characteristics. The first membrane, with the first membrane, 100% of the panelists were in agreement on the different sample, while with the other membrane, he corrected himself, which was then taken into consideration for filtration and tests. statistically, they were a lot less clear in recognizing the wine filtered at 0.2 versus 0.8 bars. In terms of difference, the membrane, with the use coupled with the use of a dynamic filtration technique, made it possible to have a much better quality. In other terms, it was preferred over the other membranes, and this is absolutely essential. Having a lot of attention for membranes, paying attention for membranes will pay back. Now, what conclusions can we draw? First of all, that AF4 and what Professor Zattoni did made it possible for us to investigate a lot more accurately from a qualitative standpoint the native colloids that are important for wine. There's another item that we need to refer to if you are looking for quality filtration, and that is that you need to find the best operational window where our membrane will allow the colloids that are desirable through, and as they get through, they are not broken. And on the other hand, we've understood that for sure a good use of capillary outside-in cartridges plus a dynamic management of filtration, a dynamic flow management of filtration, when combined, can improve filtration. And then it's important to start from quality and value to then convey the value to the idea and the design of the device that can help. I have taken up most of the time that was allotted for the illustration of the project. I would like to acknowledge the University of Bologna, the project team, including all the young people who are working with me, and there are many of them in this room, Gian Maria Zanella and Elisa Del Pre and their teams at Enologica Vason, and obviously the organization and you all for listening so attentively. Thank you very much.
Thank you so much. Let's move to the last speech by Marco Marconi. This is going to be the end of this module, and we've got some time for questions and answers. Good afternoon, ladies and gentlemen. I forgive you, Federica, because you mentioned the clarification, and this one-making technology plays a central role. As far as I am concerned, I am the last speaker for this module, and I'd like to use storytelling to tell you how we got to this solution in order to highlight the benefits of this solution, of this plant solution. So how did we get to this idea? We wanted to create an innovative filtration system that can ensure quality, productivity, and convenience in wineries. We wanted to achieve a technology that could be used to prepare wine for bottling, and we wanted to achieve a technology that can be used on all kinds of wines, given its quality. So we wondered, what kind of filtration can we use? Orthogonal filtration is the most used. It treats wines delicately, so it is very respectful. But cross-flow filtration is widespread. Cross-flow filtration has many benefits. It is convenient, it ensures productivity, and this is why it is used a lot. So this could sort of be a mission that was impossible to be accomplished, but there are other items which should be considered in winemaking: quality. So we accepted this challenge against the trend. And what did we do? We tested several membranes, and for each membrane, we analyzed the sensorial profiles of the wines through sensory analysis and organoleptic framework. So we used a tasting panel. Then we considered the filtrability index of these wines. And then with the F4, we wanted to check whether the colloidal structure could be preserved. And then we carried out the Moselux analysis, which Federico talked about during his previous presentation. So it's about foam persistency and quality for sparkling wines. So based on this analytical approach, we identified the core of the plant, the best membrane, the most suitable membrane to achieve our goal. So we selected this hollow fiber membrane in outside-in setup. As for the capillars, they are high permeable. This translates into easy permeation of wines, which entails less stress. There's a large pore structure ratio, which contributes to the previous parameter, permeability. This has a symmetrical structure, which means that it withstands stresses over time. It features a large filtering surface area in not much space. We don't have much space in wineries, so it was important to reduce the plant size. And then the material of this membrane should be inert to wine pH, and it can regenerate as well. So we identified the core of the plant, the membrane, but then it was necessary to build the piece of equipment all around this core, which was not easy. As for any kind of innovation, we had to comply with sustainability principles. Based on a holistic approach, sustainability is not only a matter of environment. It is not just a matter of environmental sustainability, but we should consider social and financial sustainability as well. In order to pull it off, in order to comply with all these principles, we optimized the plant in terms of water consumption. As this membrane can regenerate, we checked water consumption that had to be sustainable. We optimized the washing cycles, and water consumption is to 5% compared to the wine being filtered. This is a great result for orthogonal filtration. Wines must be clarified, of course. The winemaker must prepare wines for filtration. This is essential. Then we optimized the technology in terms of waste. Waste may be present with filtration sheets, for instance, or with Kieselguhr. And then the use of detergents is minimal. Detergents are used at the end of the filtration cycle or when needed. This membrane is being washed only with lukewarm water. And we managed flow dynamics properly, and we achieved consumption reduction from 0.07 to 0.11 kilowatt hour per hectoliter, so very low consumption level. In terms of social sustainability, access to resources, I have already mentioned the reduction of water consumption, energy consumption, and the reduction of waste. But the economic features of the plant were important as well. We focused on the man-machine connection. We considered physical economy, all different connections that can be easily accessed, all valves that are easily accessible. Then cognitive economy, user-friendly software that can actually help the producer and not hinder his or her operations. We optimized the flow dynamic management as well. That is managed by a computer in real time. And then organizational economy, so the optimal management of shifts in order to use personnel properly and in a sustainable way. Then, in terms of financial sustainability, in order to ensure financial sustainability, we needed to analyze data, which we did. So after processing all data, we can say that the membrane is great in terms of filtrability index. So in financial terms, what does it mean? It means that there's a perfect integration of the machine in the winery because the following processes can operate smoothly. So microfiltration by membrane before the bottling works properly. If you work in a winery, you know that this is essential. This means that we can work with no downtime to wash cartridges. Then productivity. A filtration cycle before a washing that entails 10-minute downtime entails the production of 100 hectoliter per cycle, which means 150 to 120 hectoliters per day. So if we assume a 2-month filtration season, this means that many producers can use this machine, 800,000 or 1 million bottles per year. But when we talk about membrane-based technology, we talk about modular technology. The information I mentioned concerns a basic plant, but we can have a bigger plant. In terms of financial sustainability, we can optimize the management of stages after the filtration. We can optimize one-step filtration, so no other steps that entail washings and mechanical stress. We optimized the consumption of detergents. We optimized the use of water and power, and loss of wine was minimized. by optimizing draining. So basically, the loss of wine is negligible. As for automation is essential. So there's an initial investment, but this investment is affordable. This plant has great productivity, and you have had a look at the sensorial analysis. The panelists identified wines filtered through this technology, which means that you can stand out on the market quality-wise. I'd like to wrap up. It is a technology that combines several benefits of different filtrations, production wine and filtration wise, and it uses a specific flow dynamic setup. You can come to a booth and taste the wine to check out that we did good. And so 5:30 tasting area, please come by. Then I'd like to thank the company that made the resources available, VASONGROUP. And I'd like to thank the Amazon Lab, Francesco Leonardi, who is part of this devotion, and Mr. Scapuzzi, who is an expert in filtration, who helped us a lot. So thank you so much.